Good afternoon, everyone. The authors and invited guests, welcome to the technical session 8E. Myself, Siddesh Mughal, and this session would be moderated by me. On behalf of Global
Good
Knowledge,
afternoon.
yeah, good afternoon, ma'am. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December 2025 in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like you to introduce you all to the chair of this session, Dr. Srinivasulu Go- Gogula. He, he is a professor and head of department at Vardhaman College of Engineering, Telangana, India. His academic and research work centers on deep learning, natural language processing, machine learning, and data mining. A renowned author and a researcher in the field of intelligence systems, he has contributed extensively to advancing modern AI technologies through his publication, mentorship, and leadership in academia. Due to some technical issues, Sir has not joined yet, so we'll move further till Sir joins the meeting. So let's start with the presentation. So the first presentation is presented by Saurabh Kumar. He is presenting a transparent transformer framework for English Hindi neural machine translation, design and preliminary evaluation. Sir, are you there?
Yeah, Siddesh, I'm there. Just let me wait for a moment.
Yeah.
Okay, so good afternoon to everyone and respected session chair, honorable guest and distinguished faculty members and my fellow researchers and my dear colleagues. This is a very warm welcome to you all. Like it is a great honor and privilege for me to present our research paper entitled A Transparent Transformer Framework for English to Hindi Neural Machine Translation, Design and Preliminary Evaluation. Like this work is jointly authored by Yash Mishra, Nishant Singh, Arun Kumar Rai, Aditya Kumar, and myself, Saurabh Kumar, from Department of Computer Science and Engineering, AIML, from Greater Noida Institute of Technology. It is located in the Gautam Budh Nagar in Uttar Pradesh. And today I will walk you through the motivation, methodology, architecture, and experimentational setup, results, and future of scope of our work. So, the machine translation has become the cornerstone of modern communication, especially in multilingual countries such as in India, and where language diversity is immense. While neural machine translation has achieved remarkable success for high resource language pairs, English to Hindi translation still faces challenges such as word order differences, morphological richness of Hindi, and contextual ambiguity. Like our work aims to address these issues using a transformer-based architecture while also focusing on transparency and interpretability, which is often missing in deep learning models. So, the motivation behind this work arises from three key observations. Like most existing neural machine translations behave like black boxes, offering high accuracy but little insight into how decisions are made. Like English to Hindi translation demands strong contextual understanding, like especially for long and complex sentences. There is a lack of interpretable transformer frameworks, specially designed for Indian language pairs. Hence, like our goal was not just to improve the translational quality, but also make the model more explainable and analyzable. Next, moving on to the slide. The problem statement was how we can design a transformer-based based NMT for English Hindi that achieves strong performance, like while maintaining the architecture transparency and interoperability. To solve this, we have focused on a clear encoder decoder attention visualization and controlled pre-processing, and which is reproducible through training methodology. There are some related works are also like in the previous research that shows that the recurrent neural network and the LSTM based models struggle with long range dependencies, and attention mechanisms improved results but had like a scalability issues. And the transformer introduced by the Google and revolutionized the neural machine translation using the self attention blocks. However, the most transformer implementation prioritizes performance over interpretability, so especially for low resource language pairs such as English to Hindi. Like this gap directly motivated our approach. Let's discuss about dataset. This is the some related works and overview. You can see the research paper that we have utilized in preparing this project. So, talking about the dataset for training and evaluation, and we use parallel English to Hindi sentence pairs, like carefully pre-processed to ensure the quality. The key processing step that we have used is the sentence normalization, tokenization, vocabulary limitation, and padding and masking to ensure the stable training and reduce noise in the dataset. And our proposed methodology follows a standard transformer pipeline, but with a strong emphasis on transparency. Like the steps include the input sentence embedding, as you can see in this graph, positional encoding, multi-head attention, encoder decoder attention, and feed forward layers. And then in the final softmax based token prediction. Like each step is designed to allow inspection of intermediate outputs, especially using the attention weights. You can see the model configuration here. You can also take the screenshot of it. I'm moving on to the next slide. So, uh, the key highlights of our transformer architecture was using multi-head attention that captures different semantic relationships, and using residual connections, which ensures like gradient stability. Layer normalization improves convergence, and the decoder attends the explicitity to the encoder outputs, mean it will give the contextual output. The architecture allows us to trace how source word influence the target translations, like enhancing the transparency. Moving on to the next slide. For the training configuration, the model was trained using Adam optimizers. We have used cost entropy loss. We have used the fixed number of epochs and controlled batch size. And we carefully monitored the training loss, validation loss, and the attention alignment quality. To evaluate performance, you can see the performance and analysis slide. To evaluate performance, we primarily use the BLU score, which is a standard metric for machine translation. We have used the n-gram overlap, precision of generated translations. While BLU has limitations, it provided a strong baseline for comparative evaluation. Our experimental results, it indicates consistent performance in translation, quality over baseline models. As you can see, there are state-of-the-art models comparison with our model. For better handling of long sentences and improved contextual alignment, Uh, the thing which helped us really well was attention visualization, revealed linguistically meaningful patterns, like our validating our emphasis on the transparency. To analyze our transparency, let me move on to the next slide. This is our training efficiency slide here. Like for the evaluation of the transparency, we observed the clear word-to-word alignments. and we try to reduce the ambiguity in the translation, as well as for the easier error diagnosis compared to the like opaque models. Like this makes our system valuable not only for development but also for the deployment, but also in the field of academic research and linguistic analysis. However, there are certain limitations to this. You can see the target output and the predicted output. This is usually generated by our model. I'm moving on to the next slide. And here is our attention mechanism graph for the Hindi to English translation. Sorry, English to Hindi translation. And let's discuss about some of its limitations. Despite the positive results, like our work has certain limitations, like the data set size was relatively limited, and evaluation was primarily BLEU based, bilingual evaluation understanding, and for the domain diversity, it was restricted. And this limitation opens several directions for the future work. Let me move on to the next slide. In the future, like we plan to like train on the larger and more refined data sets, integrate newer architectures such as Mamba, like expand our evaluation using Meteor and DER. This is another evaluation like parameters for the large language models, and extend this framework to like other Indian languages such as Marathi, Bengali, and etc. Let's discuss about some of these applications. This is our future work. And applications could be like the government document based translations and educational content localization and like cross lingual information access and assistive technologies. And so the final note is to conclude our project. We propose a transparent transformer framework for English Hindi neural machine translation, and it achieved promising translational quality. It enhances the interpretability through attention analysis. It also demonstrated the feasibility for the like real world applications. And I
Uh,
believe, and yeah,
Sorry to interrupt you, sir, but your time is over.
okay, okay,
Yeah.
okay, not an issue. Any more further questions?
Sir, actually, our session chair has some technical issues, so
Mm-hmm.
he'll be joining in some time.
Okay,
So till then, we don't have any questions. Is that
okay.
okay? Yeah, sir.
Not an issue, not an issue, not an issue, Siddesh.
Okay, sir. Thank you.
Uh,
We'll move
can- okay,
further.
can I
Yeah.
stop sharing the screen?
Yes, sir. Yes, sir.
Okay, let me just.
So next we have Amulya R. She's presenting age, gender, and handiness prediction using handwritten text. Do we have Amulya
Hi,
R?
sir.
Yeah, ma'am. You
I'm
can
here.
start your presentation.
Okay, let me share my screen.
Yeah, yeah. Yeah, ma'am. It's visible. You can continue.
Sir, is it visible?
Yes, ma'am. You can continue.
Okay. Good afternoon, respected chairperson and co-host, and my fellow participants. I'm Amulya R. Department of Computer Science and Engineering from MIT Mysore, with my co-authors Vismita and Vijayalakshmi under the guidance of Dr. Ajit K.N. Ma'am. Today, I will be presenting our paper titled Age, Gender and Handedness Prediction using Handwritten Text. This is our agenda. Then, coming to the introduction, handwriting is not only a means of communication but also a reflection of a person's physical and behavioral traits. It is a behavioral biometric that contains rich information about the writer. Features such as stroke direction, spacing, and pressure vary from person to person. This paper focuses on extracting such information to predict age, gender, and handedness using deep learning techniques. Coming to the problem statement, existing handwritten systems are mainly designed for text recognition. They do not focus on identifying the characteristics of the writer. Manual feature extraction method are complex and give inconsistent results. Hence, an automated deep learning based approach is required. So, coming to the literature survey, as part of the literature survey, 16 research papers related to handwriting analysis between the year 2022 2020. Most of existing works are based on dataset prediction. These methods shows good accuracy. They are not evaluated in real-time scenario. So real-time analysis remain unexplored. Our work is focuses on building a generalized and real-time implementation. The main of this work is to analyze handwritten text using deep learning and AI model. We aim to automatically extract writer-specific feature using a CNN model and Gemini AI model. Use these features to predict age, gender, and handedness of the writer. It improves prediction accuracy also. So, coming to the data set, we took online data set which is open source, and before the training we have to do some pre-processing for the images. They are image resizing, which all handwritten images are resized to fixed dimension like 225 pixel to 325 pixels. Then auto orientations. Images are automatically aligned to correct small rotations or skew introduced during scanning or capture. This helps the model focuses on handwriting pattern instead of orientation variation. Then grayscale conversion, which color images are converted into grayscale to reduce computational complexity. This preserves essential stroke information while eliminating unnecessary color details. Then coming to contrast and brightness adjustment. Contrast and brightness are adjusted through enhanced faint and unclear handwriting strokes. Coming to noise reduction and background cleaning, noise such as ink smudges and background to remove from the images. This ensures that the model focuses only on meaningful handwriting information. Cropping and padding. Images are cropped to isolate the handwritten region and remove empty background space. Data normalization. Pixel values scale to a standard range and speed up model training. The coming to data augmentation techniques such as rotation, shifting, and zooming are applied to increase data diversity. Data normalization is pixel values are scaled to a standard range to stabilize the speed of model training. These are the samples from our data set. One is female right hand and another one is male right hand. The model we use CNN model, which is work like it contains input layer, convolutional layer, pooling layer, flattening layer, fully connected layer, and output layer. From this image, we can analyze the input layer process the start with handwritten text image. Image is resized, normalized, and cleaned before being given as input to the CNN. Then convolutional and pooling layer. The image then passes through convolutional layer where the CNN extract lower level features such as stroke, edges, curves, and written patterns. The flattening layer, it extract map or then flattened into one-dimensional vectors. Fully connected layers is combine all extracted features and make the final prediction. The output layer will display the output like age of the person, gender, and their handedness. Handedness means right hand or left-handed person. Coming to the system architecture, we have input image, which is the input that capture from webcam or we can upload from the computer. Yeah. Coming to the system architecture, we have input image, which is the input we can give from webcam or upload. Then go to pre-processing steps. We have resizing, grayscale, normalize pixel values, and remove noise to create uniform input. Then it goes to segmentation, which is help to reduce background and focuses on model on informative areas. Then coming to the feature extraction, the CNN model extract some features like stroke, curvature, textual features, etc. automatically. It replaces manual features. Then classification, fully connected layer convert extracted features into class. So we use separate head for each attribute like age, gender, and handedness. For prediction algorithm, we have used two algorithms, CNN and Gemini. Gemini is just for a real-time prediction because we need plenty of data set for real time. So we use Gemini for prediction algorithm. Then
Ma'am,
it connected.
sorry to interrupt, but your 9 minutes are over. Kindly wrap up.
Okay, can I conclude?
Yes, ma'am.
Yeah, this is our CNN based system, handwriting analysis, which used to predict the age group of writer, gender, and handedness of the writer, which is extract feature automatically. Then coming to the future work, we can use the model for larger and more diverse dataset and for multi-language purpose and cursive handwritten. It's applied for advanced deep learning models such as hybrid CNN transformer architecture. Then coming to the applications, we have used it for mm, forensic and educational purpose. Any questions, sir?
No, ma'am. Thank you.
Thank you.
Moving further, next we have Samyak Pawar. He is presenting AI-powered border intrusion detection system using satellite imagery. Samyak, are you
Hello.
there? Yeah,
Yes, yes,
you can start your screen sharing.
yes. My screen is visible, sir.
It's loading, Samyak. Yeah,
Okay.
it's visible now. Go ahead.
Respected dignitaries, honorable panel members, respected guide, and dear audience, good afternoon. We are presenting our final year project titled AI powered border intrusion detection system using satellite imagery. This is carried out under the guidance of Dr. Swapnil Deshmukh, Associated Professor, by our team members Samyak Kaur, Sanket Rasa, Kumkum Hari, and Ashwamedh Ritti. Today, I will briefly walk you through the problem background, literature insights, and research gaps, our proposed AI based solution, system architecture and methodology, results, conclusion, and future scope. Border requires continuous, accurate, and reliable monitoring, especially in geographical challenging regions. Traditional surveillance systems generate a high number of false alarms and are reactive rather than proactive, depend heavily on human monitoring with advancement in artificial intelligence and satellite imaging. We now have the ability to automate detection of suspicious activities over larger border areas. Our system combines AI-based anomaly detection, satellite imagery for wide area coverage, and optimal sensor fusion for higher accuracy. We have done literature survey. We studied extensive research across intrusion detection systems, thermal and satellite-based surveillance, and machine learning and deep learning techniques, multi-sensor fusion approaches. Existing work shows strong results in localized detection, but scalability and real-time monitoring over large border remain limited. These are our research papers, their authors, titles, and objective and limitations of their research papers shown here in literature survey. So from our literature review, we identified key gaps like most systems rely on ground-based sensors. Satellite data is underutilized for real-time intrusion detections and high false positives due to environmental changes and also limited AI models for temporal change detection. These gaps motivated our research. India's borders span diverse and inaccessible terrains. Manual surveillance in such regions is costly, risky, and not scalable. Our motivation was to build a technology driven intelligent surveillance framework that minimizes human dependency while maximizing coverage and accuracy. The problem we address is India's vast border areas make traditional surveillance slow, error prone, and reactive. Small scale intrusions such as temporary camps, trenches, unauthorized vehicles often remain undetected. So, the objective is to design and develop an AI-powered border monitoring system that autonomously analyzes satellite imagery to detect suspicious changes and generate near real-time alerts. Scopes are AI-based monitoring of border regions, detection of unauthorized movement, real-time alert generation, prototype level implementation, and objectives are like develop accurate AI models, differentiate between environmental changes and intrusions, maintain high accuracy across trains and lighting conditions, use open source satellite data sets. Now there is system architecture. Here we can say how the how the project works. So our system architecture consists satellite acquisition, continuous retrieval of high resolution imagery is done, and after that AI powered analysis engine is there. Change detection and anomaly classification is conducted here. Then after if alert is generated. So alert generation module is there. Risk scoring and notification occurs on the desktop. So web-based dashboard is also there. Visualization and design supports is done there. This modular architecture ensures scalability and future integration. So algorithms are like we employ a combination of NDVI for vegetation change detection, change vector analysis CVA for multispectral variations, deep learning modules such as uh, convolutional neural network, vision transformers, LSTM for temporal anomaly detection. This layered approach significantly reduces false alarms. Our solution enables continuous satellite-based monitoring, automated anomaly detection, instant alert generation. The system ensures proactive surveillance, shifting border security from observation to prediction. For our project, requirement analysis are functional requirements such as automated satellite image processing, intrusion classification, alert visualization. Non-functional requirements, scalability, reliability, high accuracy, secure data handling. Hardware includes GPU-enabled servers, while software uses Python, TensorFlow, PyTorch, and web frameworks. This is a UML diagram. So UML diagram illustrates interactions between data injection modules, AI inference engine, alerting system, and user dashboard. We can see here the whole UML diagram. So in conclusion, we combine satellite vision and AI to build a smart, scalable, and real-time border surveillance system. Our approach transforms passive monitoring into proactive defense, especially for remote terrains. And in this project, future enhancement include UAV-based live monitoring, radar and thermal sensor fusion, transformer-based change detection, edge AI deployment near border posts. These upgrades will further reduce latency and improve accuracy. Thank you for your valuable time and attention. We will be happy to answer any questions.
Our session chair is here. Sir, do you have any questions for the presenter? Let's move further. Next we have, let me share my screen. Yeah. So next we have Shiva Sharon A. She is presenting an exploratory survey on Government Mitra, a digital governance portal using web scraping and chatbot services. Shiva ma'am, are you there?
Yes, I'm here.
Yeah, ma'am.
One second. I will screen share. My teammate Shakti will screen share the presentation.
Okay, ma'am, no worries.
Okay. Is the presentation visible for everyone?
Yeah, ma'am, it's visible.
Okay. Good morning, everyone. I'm Sheba Sharon, and the paper that I'll be presenting is titled An Exploratory Survey on GovMitra, a digital governance portal using web scraping and chatbot service. The authors are Sheba Sharon, Shakti Maheshwari, and Dr. P. Revati. And this PPT is presented by Shiva Sharan and my teammate Shakti Maheshwari. We belong to Rajanakshmi Engineering College in Chennai and to the Department of Computer Science and Design. Moving on to the introduction. So this is the outline of our presentation. First, we have the introduction, followed by the objectives of the project, then the literature survey, then the proposed solution of the chatbot, then the technology stack that we're using to build it, and the methodology of how it works, followed by the system design, and then the conclusion. Introduction and the motivation for this project. So, government websites in India are often difficult to use because they have very difficult interfaces and it's hard to navigate through many pages to find the exact answer to your query. And they tend to have outdated designs and technical glitches here and there. And they often do not have a proper mobile compatibility. As a result, a survey shows that 58% of users find it difficult to navigate through these websites, and almost 61% would use these e-governance services if they were provided a proper guidance or if the website had a chatbot service. So, this research highlights that there is a need for a solution that provides a more accessible way and much more simplified navigation to access these government services by people living in all regions of India. Next.
Here are the objectives of our project. Firstly, our goal is to make a unified multi-service chatbot. The idea is to combine multiple services into a single chatbot so that users don't have to visit different platforms and they can access all the required information in one place. Secondly, it's the multilingual and regional language support. Our system supports multiple languages, including regional ones, to make it accessible for a wider and more diverse user base. Third, personalized and efficient service delivery. Our chatbot understands user queries and provides accurate and relevant responses quickly, improving efficiency and user experience. Fourth, user-friendly interface for accessibility. The interface is simple and intuitive, ensuring that even non-technical users can interact easily with the system. Finally, our system is scalable and its design is modular. This architecture allows easy expansion so that new services and features can be added in the future. These are the existing chatbots related to our project. Uh, Even though they are available for everyone to use, they lack any language support. Disha, the railway chatbot, and Metro WhatsApp bot provides only English language. And these chatbots are limited to button based options and do not support conversational queries. Aadhar Mitra is a chatbot for simplifying doubts and queries regarding application of Aadhar and Aadhar services. It provides English and Hindi languages, but it can understand only fixed format queries. Moving on to the solution.
So the solution that we thought of was an AI-powered multilingual assistant chatbot that enhances users' access to government services. It aims to simplify the complex website that has many unnecessary content, and it provides a much more easier to follow instructions and a proper guidance to properly understand the user's query and to answer it. And it also provides a very inclusive and user friendly access across various demographics and for people living in various regions across India. And beyond e governance support, Gaumitra also assists citizens with access to information about bus routes or metro routes and etc. And it also comes with government services such as Aadhaar card based services and PAN card application based information, bus routes and passport facilities and income tax service based queries. And it aims to make digital governance much more reliable and accessible. Next, this is the technology that we'll be using to build Gaumitra. First, for the front end, we decided to go with HTML, CSS, and JavaScript. So, this can be used to build a simple and a responsive website that is also compatible with mobiles. And next, for the backend, we're using Python. So Python acts as the main connector for the Rasa framework and for the data collection and also for external API integration. Next, this is the most important part, the chatbot part, and we're using Rasa framework to build the chatbot. So Rasa provides a conversational chatbot and it also has intent classification that is able to understand what the query is asking for, and entity recognition, the ability to understand keywords that are present in the query, and also dialogue management. It allows for a back and forth conversation with the user to understand their need and to respond to it properly. Next will be for the data collection part from the websites. We plan on using web scraping libraries in Python such as Beautiful Soup, and Scrappy. So we'll be web scraping the relevant information from websites for schemes, services, exams, and passport based facilities, PAN card based facilities, licensing based websites, and etc. Next, all this web scrape data will be stored in a database. So we plan on using a JSON based database that has the proper title or the domain for it and the relevant information according to it. This can be used to store the information and to validate it, and it's also efficient for efficient retrieval during the chatbot response process. Last but not least, we'll be adding a multilingual support. So this multilingual support aims to translate the query or the information from English to a native language and from a native language to English. So there are many languages such as regional languages such as Hindi, Telugu, Tamil, Malayalam that aren't necessarily included in websites. So we plan on adding this through available APIs on the internet, such as the Google Translate API, which provides a much more reliable and a real-time multilingual response, and intake trans model that is used for translation between Indian regional languages and English. Next.
We have divided the methodology of our project into 3 distinct steps. First step is the web scraping and data gathering part. Here, the relevant information about government schemes, services, and exams is collected from official government portals. Web scraping techniques are used to extract both structured and unstructured data. This data is then stored in a centralized base for efficient retrieval. Next, we will be using the conversational framework using RASA. We use RASA to build the chatbot's core functionality. It handles intent detection and intent classification and entity recognition to understand user queries accurately. Dialogue management is implemented using RASA stories and roles to maintain smooth and contextual conversations. Finally, multilingual processing. The system supports multiple Indian languages through automatic language detection. User queries in regional languages are translated into a processing language for NLP, and then the generated responses are translated back into the user's preferred language. This ensures inclusive and accessible communication for all users. As you see, this diagram represents the systematic flow of our chatbot. The user submits a query through the chatbot interface. The query first passes through the multilingual model where the language is detected and translated if needed. The processed query is then sent into RASA where NLU identifies the user's intent and entities, and RASA core manages the conversational flow. If required, custom actions fetch relevant data from the database, which is built using web scraped information from official government portals. The response is then translated back into the user's preferred language and displayed through the chatbot interface.
In a nutshell, Gaumitra aims to provide a unified
Ma'am, sorry to interrupt, but your 9 minutes are over. So kindly wrap.
Okay. Yeah. So Gaumitra aims to provide a unified and an intelligent chatbot solution that makes government services, schemes, and exam-based information more accessible. It combines web-scraped government data, a RASA-based chatbot, and multilingual support that makes the conversation more accurate and user-friendly. Its scalability allows for future enhancements, making Gaumitra a reliable step towards a more inclusive and efficient e-governance. Thank you.
Next, we have Pavitra Shivakumar Mundasad. She is presenting bone marrow cancer detection using deep learning algorithms.
Sir, just a second. She is joining in. Can we just present after the next team?
Okay, okay. We'll move further. And is it fine if I move your presentation to the last?
Yeah, sir. Okay.
Okay, I'll move it to the last. Thank you.
Thank you, sir.
Let me share my screen. Next, we have Sonam Dubey. She is presenting enhancing weather prediction accuracy using machine learning algorithms, a data-driven approach.
Yes. A very good afternoon to all of you, Chairperson sir, and
can you put it in a slideshow mode?
yes, sir.
Yeah. Ma'am, there is a, yeah, you can put it on.
Yes, sir. Yes, yes. A
Thank
very
you.
good afternoon to all of you. And I am Professor Sonam Dubey, and my co-authors is Dr. Preetas Yadav, and he's my guide also, and me, Sonam Dubey. And I'm from the Computer Science Engineering branch, and I'm from the Bhopal. And my topic is enhancing weather forecasting accuracy using the machine learning algorithm, a data-driven approach. Now, This is my abstract. Forecasting plays a crucial role in various fields such as business, healthcare, and weather prediction, and business analytics, and in the for the weather prediction. But it has some restrictions like handling the large scale data and high dimensional data and non-linear data. So for this purpose, we have introduced the machine learning algorithm that basically used for to reduce these kind of things. Now, these are the contents and introduction, research methodology, literature review, problem statement, implementation, result analysis, and at the last conclusion and future work. Now, the introduction. The weather forecasting is nothing but a scientific process of predicting the atmospheric condition of a particular place and time in the future. So it basically involves the analyzing data like the temperature, humidity, and air pressure. So in this weather costing, basically have the various sectors like an application in agriculture, disaster management, aviation, and transportation also. Now, the second is research methodology. In research methodology, we have include the following steps. The first one is data gathering and pre-processing. In the first step, firstly, we gather the data from the different data set, particularly in this section, we have include the data from the NASA climate data repository, weather, financing, market, demand prediction data, and also include the meteorological agencies data. And in the second one, machine learning model selection. In this site, we have chosen an appropriate ML model, basically for the forecasting. In this model selection, we have used different types of models like linear regression, decision tree, random forest, and gradient boosting machines, support vaccine, machine, and artificial neural network. And all these algorithms following data. And the next one is model training, hyperparameter tuning. In this section, we have just selected the ML models, which are basically used to scale over the old data. And the data set is naturally divided into the two basic things. The first one is training data, and the second one is testing data. In this both data, we just first train our data, which are already available, and just train our data for the testing purposes. And in the fourth section, we have included the model assessment and performance metrics. In the model assessment involves the testing the models on the validation and test data set. After the testing, we just find out our data is accurate or robustness and consistent or not. If it follows all the things, we just perform the following test. In the next one is comparison with the traditional forecasting models. In this site, we have
Ma'am,
already
sorry to interrupt, but your
regression
voice is.
models.
Hello, ma'am. Your
Yes,
voice is
sir.
breaking, ma'am. Between. Your voice is breaking, ma'am, in between.
Okay, sir. Yes, yes, sir.
Now it's
Now the
okay.
fifth one is comparison with the traditional forecasting. Yes, now it is audible. Hello.
Yeah, ma'am, it's audible. Continue.
Yes, sir. In the fifth one, we have compared the different traditional forecasting models which are previously used, and for this purpose, we have studied different types of literature surveys also and compared the previous results. And the next section, distribution and best performing ML model, is find out we have just applied in the real-time forecasting platforms and also use the various APIs, ACE computing systems, and continuous update. Now, the challenges and future consideration in ML-based forecasting include the various data qualities issues like model interpretability, computational complexity, and scalability also. And in the future research, we have just focused on the improvable, explainable AI methods, just integrated with the all machine learning models and machine learning techniques like deep learning and other methods also. Now, literature review. So in this section, we have studied more than 20 papers for this purpose. And the first one is Introduction to ML in Weather Forecasting. In this approach, we have just used the numerical weather prediction model with the physical equation and find out the different shortcomings. And the second one is statistical and machine learning approaches in weather prediction. Hello, the voice is audible.
Yes, ma'am, it's audible.
Hello. Okay. And the next one is statistical and machine learning approaches in weather prediction. In this approach, we have previously already studied the different types of models like ARIMA, will ML-based approaches like AI, ENN, artificial neural networks, support vector machine, and decision tree. And in this research, we have just find out the and the third one is neural networks and deep learning in weather forecasting. In this technique, we particularly use the recurrent neural network and long short-term memory networks, which basically have the ability in weather forecasting with their dimension and various dependencies. And next one is ensemble method and boosting machine, random forest, and hybrid models. We have used the combination of both techniques with the physical model and just find out the accuracy of the model. And in the next one, real world uses of ML in extreme weather predicting. In this paper, we have just forecasting extreme weather events such as hurricanes, tornadoes, and heat waves, and we have studied in the neural network also. Now, this is the comparison table of literature servo. In this app, in this thing, we have different categories are also given dependency, in which we have seen different types of models or the accuracy. Now, the problem is statement. There are three major issues when while using the weather prediction in machine learning model. The first one is data availability and quality. Various MS model depends on the high quality and real time meteorological data, which are sometimes not accurate. So first we do the on that thing, an incomplete, unpredictable, and noisy data set, which have also have various errors. And the third one is model interpretability. Now in implementation sections, we have just step out the data gathering and pre-processing, in which we have included initialize components, loading and processing, and just display the statics and also see the visualization. And the second part, we have prepare the data for data to model. In this model, we have just categorized the data into test and training models, and making some prepare and evaluate the models with the previous traditional models and find out the accuracy of all the models. And at the last one, machine performance matrix also given, and all the algorithms which are used for the weather prediction we have shown in the figure. And the last, model training and assessment. So these are the comparison. And in this diagram, we just see the temperature trends. And in this correlation matrix of weather variables. So these are the variables like temperature, humidity, pressure, and precipitation. And the result analysis just show the deep learning model after implementing and testing various machine learning models on the real world data sets. Several key observations have made regarding their performance, like deep learning model with the long short-term memory network, and also with the help of artificial neural network, and also demonstrate the accuracy in time series forecasting task also, and their ability to capture the complex temporal dependency and non-linear patterns enable them to produce more reliable and dynamic predictions. And the second one is ensemble method. Ensemble method basically depends on the random forest method. In this, we have so the high accuracy in structured structure forecasting problems in traditional model like ARIMA and simple regression models, and also outperformed by the ML models. Now, conclusion and future work. So before conclude it, we have seen machine learning algorithms have transformed predicting by improving accuracy, flexibility, and scalability. And while all statistical models remain beneficial for the simple estimating task, but in current scenario we have seen due to the large complex data and complex numerical predictability, we have used such kind of integration techniques like ML with the deep learning, ML with the physics methodology, and ML with the AI technologies. And ML techniques offer high performance for the large scale and complex data set. In future research, we can also focus on developing the AI models for the weather prediction, which gives the better interpretability and integrating. So while leveraging advancement in ML, business and researchers can make more informed decisions based on the reliable predicting insights. Thank you, sir. Hello.
Yeah, ma'am.
Any question?
Sir, do you have any question?
Am I audible?
Yes, sir, you're audible.
Yes.
Thank you very much. I don't know the reason why I'm facing some sort of technical glitches. I appreciate Sunil Devi for presenting your idea. Ma'am, can you tell the real-time applications of your idea?
In weather forecasting.
Because it is so generic, right? Instead, do you have any specific application or specific locality that's where your model can behave properly?
Yes, I think in for various field we can use this, like one second, sir.
All right. Can you go to result section, ma'am?
Yes, sir.
Yeah, comparison. Slide number 7. So 11, 11.
11, sir.
Yeah, ma'am. 11.
Sir, 11 or 7 or 7?
11, 1, 1.
Okay, 11. Yes.
If you look at this slide, you have mentioned so many popular algorithms which are part of this weather forecasting. So out of which, what are your own algorithms that you have implemented?
In this section, sir, I have, okay, I'm showing. Sir, I am using the RNN.
RNN. Can you please
Ye-
elaborate like how RNN can help you in predicting the weather?
Yes, sir.
Can you please bit elaborate about how RNN can help you in predicting of weather forecasting?
Just a second, sir.
Please.
Sir, actually, neural network has the various properties like we have just studied the various things like neural network, and we have just used in the used with the ML model.
What is the significance of RNN?
It actually sir, it gives the highest accuracy, especially for the weather forecasting, and it just easily find out the weather patterns. And we can easily find out the patterns with the spatial data.
Okay, ma'am. It is somewhere deviating from the discussion. Thank you.
Okay, sir.
Hello, sir. Sir, actually, sir, Hridyansh has requested to move his presentation next because he has some urgent situation to attend. So, can he present next?
No issue. Please go ahead.
Okay. Thank you, sir. Thank you, everyone.
Okay.
So,
Thank you, sir, for making the arrangements.
yeah, let me. Yeah, so Ridyansh Mahajan
Okay.
presenting Sugar Phase Search Phase 1, an AR VR based deep learning framework for surgical sense analysis. Yeah, Ridyansh, now you can go ahead.
Yeah, I'm sharing my screen right now.
Yeah, it's loading.
Uh, is everything visible?
No, it's still loading, Ridyansh. Yeah, it's visible now. You can go ahead.
Uh, so, good morning, esteemed session chair, fellow researcher and attendees. I am Rityash Mahajan from Department of Computer Science at Thapar Engineering of Institute of Engineering and Technology, and today I'll be presenting our research titled Surge Phase 1 Deep Learning Framework for Surgical Scene Analysis. And the authors are like me, myself, Shubham Singh, Sanu Joshi, Anushka Fogart, Anmol Puri, Jeannie Goyal, and Dr. Sachin Kansal, all from Thapa Institute of Engineering and Technology. So, moving on to the problem statement. To understand the motivation behind surge, we must first look at the systematic limitations of current surgical training paradigm. So, the traditional surgical open surgery models heavily rely on cadaveric dissection. While this approach is very foundational, but it is constrained by resource scarcity, high ethical regulations, and most critically, the limited amount of times you can perform surgery on a cadaver. Once an incision is made on a specimen, for example, the same incision can never be recreated. Furthermore, assessment in the open surgery domain lacks subjective and standardized metrics for validation. So our solution, Surge, as illustrated in the two cards, consists of two parts: the deep learning module along with the VR simulation module. Now let's like discuss the architecture in greater detail. So before moving on to the architecture, we have we are we have heavily focused on data-driven robustness. Uh, an AI model is only robust as the data it learns from. So we ensured high quality, consistent data. And a novel approach is to use egocentric data. Basically, we employed egosurgery dataset, which comprises of 4.5 million annotated frames along with 33 hours of video captured from first person perspective. That very first person perspective highlights the egocentric point of view of data. So since this is like open surgery based, and we uh, open surgery based, and we need to like match the perspective of surgeon's eye view. So using a normal third person camera would lead create motion blurs and occlusion patterns. So this is again, our deep learning module is divided into two sub modules. First of which is segmentation module. So we employed HFFnet, which stands for Light Hierarchical Feature Fusion Network. And please focus on the attention gates in the architectural diagram. Unlike the traditional unit architectures used for segmentation, which like fail in complex scenarios of open surgeries, as the skip connections in unit architecture allows for the transfer of noise along with the relevant information. But due to the novel attention gates employed in this very architecture, these architectures suppresses the irrelevant background regions and amplify the activations that are only needed. So these are the results we obtained from our segmentation model using LHFFnet. You can see on the left side the and the segmentation created by the model itself only, and empirically we achieve 14% improvement over the state of the art varifocal net model that was trained on the very ecosurgery dataset only. Now moving to the second part of our deep learning module. So obviously, so first part basically the segmentation module captured which tool, which tissue or hand or what kind of object is there in the scenario. But to understand the surgical procedure, we also need to understand what's happening over time and which phase is happening. So there's a need of spatio-temporal analysis. To address this, we employed a CNN transformer, a hybrid model which has a ResNet 50 backbone. The ResNet 50 backbone extracts spatial features which are then fed into the transformer encoder. And the self-attention mechanism of transformer allows for a global receptive field. Uh, so, for example, it can link, for example, an incision made at a second minute to the stuttering did at, for example, the end of the surgery. And below is the architecture, custom architecture that we designed and trained over ego surgery dataset only. And moving on to the results of face recognition model, on the left side you can see the faces predicted by the model. Uh, Given the scarcity of space, the labels are not visible properly, but we can show you the demo after the PPT. And empirically, we achieved 24% precision improvement over the state of the art model on the ego surgery dataset. Again, now moving to the body part of our approach. So we made a proper functioning VR module in Unity, and we utilized anatomical models such as Z anatomy, which are open source and optimized for high frame rate rendering. A key feature here is to use vertex displacement along with finite machine for organ interaction. The simulation enforces procedural rigor. For example, considering to an appendix surgery, appendix object transition from a static mesh to a physics enabled rigor body only after the user successfully performs the dissection. That means the model being high fidelity but also is pretty resource efficient. This ensures user correctly learns from surgical data flow. And moving on the conclusion, in conclusion, search phase one, as in phase one, demonstrates the feasibility of intelligent surgical digital twin using a AR VR environment. We integrated dual AI component, which is highlighted before, like segmentation module along with spatiotemporal module. By coupling this with high fidelity VR interface, we laid the foundation for a scalable cost effective training platform that moves beyond the limitations of cadaveric surgery. And as considered with future work, our immediate roadmap follows closing the loop. Currently, our AI model analyzes video data and VR provides simulation. In further phases, we want to combine these modules, close this loop, and further introduce hardware such as an haptic feedback glove to introduce sense of realism along with reinforcement learning to adjust complexity and to introduce scoring mechanisms. And again, using both of these, we can integrate them into we can integrate both of RL and haptic feedback to generate a real-time experience and real-time AI feedback system that will cost effectively and scalably revolutionize the open surgery paradigm. So that's it from my side, and these are like the reference works site which we like learned from a lot and cited in the research paper. And I would like to thank Thapa Institute and the Department of Computer Science, and along with the special thanks to Ego Surgery Dataset for providing such precious and such sensitive dataset to for our research purposes, and to all my colleagues and mentors who supported us in the development of this paper. And this is the detailed
This
uh, result, and this is the video demos. If you like, if you would like to see them, I can show it to you, and that's all. I'm open to any questions.
Hi, Hridansh.
uh, Hello,
It's
sir.
very good presentation.
Thank you.
May I know the basic intuition of selecting this idea?
So the domain or the methodology?
No, what is the basic intuition that why you have get this novel idea?
So, sir, first of all, we were like as considered with our like projects and background. So I am very from the very deep learning and AIML background, and along with my mentors, we want to create something that would have a real world impact. Along with we after scoping many research papers, we looked at the gaps specifically in the open surgery domain. The modern research papers highly target minimal invasive surgery, and they have like completely revolutionized that domain using AML. So our focus was to fill the gap for open surgery domains. For example, an appendix surgery or a knee surgery or a dental surgery has to be open, regardless of cause of the like inherent medical procedures. So we wanted to employ uh, the domain of AIML along with AR/VR technologies to make the medical and surgical process more scalable and cost effective. I hope
Good.
I answered your question. And if you were
Yeah,
looking
I
for
got your
something else.
point actually. Good. Do you think that by integrating AI with VR, does it really helps to the end user, or it will?
Uh,
Oh.
Yes, sir. Uh, yes, I do believe, and as per the given scenario, in most generic scenario, for example, if we train a model on real world data and then employ it on AR, VR, 8 times out of 10, it won't work. The reason is because of the perspective view, and that's where the egocentric data sets come in. So we employed the egocentric data. We trained the model on egocentric data, and we employed a high fidelity AR/VR interface. So that ensured that our model would work effectively on the simulated environment. As
So how digital twins helped you?
how can you uh,
No, at which
be more
context?
specific?
Yeah, at which context the digital twins help you?
Sir, so as in, for example, in open searches, you need cadaver in real life. So cadavers are first of all very expensive. There are ethical needs around it, and again, you cannot reperform a surgical action on the similar cadaver again. So in that regard, for example, for the very beginning trainee, you can train the surgical trainee or the resident on AR/VR system, and in the very later stages, you may shift them to cadaver training, which would likely minimize the cost for the hospital or the medical institution, along with tackling many ethical needs around the cadavers.
Okay, thank you, Hridesh.
Okay, thank you, sir.
Over to organizers.
Thank you, sir.
Yes, I'll stop sharing.
Next, we have Snehal Alves. She is presenting real-time data visualization platform for smart cities to monitor sustainability metrics.
Good afternoon, everyone. I'll share my screen.
Yeah, ma'am. Just a second.
Is my screen visible?
Yes, ma'am. Yes, ma'am.
Okay. Good afternoon, everyone. My name is Snehal Alvarez. I'm from ATME College of Engineering, and I'm going to present you my major project publication, which is I've given for the publication. The topic is real-time data visualization platform for smart cities to monitor sustainability matrices. So let's go with the introduction. We know that cities are facing major problems such as traffic congestion, poor air quality, changing of the weather, and many more. So for that, we are trying to bring a real-time solution. So existing methods rely on very hard to maintain physical infrastructure and costly IoT devices, which are not even scalable. This project of ours will give a web-based platform to the user where a user can see the computer vision. The computer vision is nothing but which allows computer to interrupt and analyze visual data from images and videos. And APIs. APIs are used to monitor the traffic. We are using machine learning over here, and we are even trying to show the air quality, how the air quality is data is, and weather conditions in real time. The interactive dashboards, we are making an interactive dashboard which is and cost effective, which is easy to use, and which helps the city planners. Let's go with the problem statement. Like we know, the problem statement is the existing system is very costly, and the hardware is very difficult to be used. Now the current situation we are using is the hardware. The cities are struggling to scale the system across the different sustainability areas, and there is a strong need for a simple and flexible platform. There is no, it is not a continuous monitoring urban condition. There is no particular system right now currently available which is continuously monitoring these things. Let's go with the objectives. The objective is to detect and monitor traffic density using machine learning and to fetch the real-time data which is of the weather and using the APIs, and to give the suggestions for the waste management using we have done using AI bots, and to integrate and to visualize all this data in a web-based interface. Let's go with the existing system limitations. Yeah, now as I said, we usually now the current system is hardware-based monitoring, where it relies on IoT sensors, RFID tags, pressure plates, which are very costly and which is not scalable, and fragmented data sources, where the data is unified but and requires manual monitoring of a system. Let's go to the proposed system. In proposed system, first thing we have done is traffic monitoring. That is, we have used OpenCV, which is used for the object detection for the real-time traffic analysis, and instead of physical sensors, which is very costly. And the second thing which we have done is weather and pollution tracking, where for the weather we have used weather and air. We have used APIs from third-party APIs, which is very trusted. And for that, from where we are going to fetch the data for weather and air quality dynamically. And all these are unified in a dashboard, which is visible in a dashboard. The methodology which we have used. First layer which we are used is data sourcing layer, where we are using external city data APIs, where we are going to show the live traffic data weather APIs, from where we are going to take live traffic API, which will give us the vehicle volume and the congestion points. The weather API is going to give us the temperature forecast and alerts, and the air quality API is going to give us AQI, that is air quality index, and PM 2.5. And we have did for a waste management, we have given an API which will give us like a chatbot, which is going to give us the suggestions how to dispose the waste. The second layer is the data ingestion and the processing layer, where the API scheduler and fetcher is being used, where it will periodically it will make an request from HTTP API request to all the external providers, which we have been using. Next, the we use is data normalizer or the adapter, which converts the data API into unified structure, internal structure. Next is the data processing engine, where it is used for the filtering of the data which is incoming and detects the anomalies and raises the alerts. Next is the data storage layer, where we are using a centralized storage, where we can see the historical queries and data, and optimize for a optimized time series for traffic, weather, and air quality. Next is application and API layer, where we are using backend REST API, which gives us the serves as the dashboard UI, provides the analytic summaries, live data activities, and system reports. Notification and alert module, which gives us the alerts in our dashboard UI. And the fifth one is the front end presentation layer, where we use the web dashboard, which is UI, where we can see the traffic, weather, air quality index, and the alerts in charts, summaries, and tables. And we have given also a settings option, where we can change the settings, and even we can select the city, whichever we want. The sixth one is system monitoring and admin, where we are going to where we have performance monitoring, where it tracks the API latency and database load, and user admin management, where he manages the panel and displays user displays. We can at the side we can see a diagram where it contains external APIs of traffic, weather, air, and waste, which has been collected using API fetcher or scheduler, and later it is sent to the data processing and the data adapter and processing, where the data is being filtered and it is sent. And in the centralized database, the data is being stored. Actually, centralized database is the primary major, and we can even store it in the cache if we want for the faster access. Here we can from here we can access backend REST APIs, dashboard of the UI, and the alert engine is been connected to it. And coming to the results, this is how our page looks like. We'll give our details such as credentials such as email and password, and we'll sign in, where we'll get a page like this, which is an overview. If we have given a recent, we had checked for Mumbai, so it has given for the weathercaster for Mumbai. Whichever we use for the recent cities, that data will be showed in the overview, where it will show the live traffic volume, weather, and today's query, and everything current weather in a particular box, which is going to give us which city we are searching for, what is the humidity, what is the pressure, wind, and visibility, and the traffic volume in a we are giving it in a line graph, which changes duration while changing when the data is being changed. And when we come to the second point, which is traffic analysis, here we can give here the data has been showed total vehicles, how much vehicles are there, what is the peak hour. If we have given the Mumbai, so in Mumbai, Bandra Kurla is the top location where there is more traffic, and which is the more traffic which is given, that is a car. And there is a pie chart distribution of the traffic, how it has been shown. And we have even have hourly traffic pattern, where it is going to show us at what time the traffic is high. And if we want to select any kind of particular cities, we have a select city option, where we have given a scroll bar option, where we can just check whichever we want, whichever city we want. And there is something called as traffic analysis over here. When we click on this traffic analysis, we can give the data manually if you want to check for a video or a photo how many vehicles are there. So we can just add it in this file, and we can just give it, and we can just upload and run it over here, where it is going to detect the images to a certain extent. Next topic is weather monitoring. In weather monitoring also we will select a data, or if we want the location, like particular location where I am currently in, so we can use.
But your 9 minutes over, so kindly wrap up.
Okay, weather monitoring, where we are going to monitor the weather, how the weather is, and what are the contents of the weather using the line graph. And we have a waste management AI, where it is going to give us the suggestions of the waste management, how to dispose the batteries and all. Next is air quality, where we are going to select a city where we are going to check the air quality, and it gives us the data, what are the contents of the air. And yeah, this is the system implementation, the technologies which are used. For front end, it is React.js, HTML, CSS, and JavaScript. Back end, it is Python and Flask. For traffic analysis, we are using computer vision, which is YOLO model, which is of CNN architecture and OpenCV, Python. And weather data processing is Open Weather Map, API, and Request and Pandas. Air quality index is IQ Air API and Request and Pandas. Waste management is AI assistant, which we are given. And data visualization is using charts and graphs, which is going to give, and React.js. Database management is PostgreSQL, which is in the Supabase authentication. File storage and uploads are from Supabase storage. AI insights and recommendations are from machine learning models and rule based of AI logic. And the conclusion is, the project which we have done is it is software based, so it is going to store it in PostgreSQL. The data has been stored in PostgreSQL. The APIs are from third-party APIs, and we don't have to use your IoT heavy IoT infrastructures, but we can use. It is very cost-effective and scalable. Thank you. Is there any questions?
Thank you, Snehal, for your presentation. You have covered so many components. Did you come across any existing system related to it?
So like existing system, if we go for weather forecast, we will have a Google weather forecast, which we will usually give. And if we see like traffic monitoring or something like that, there is no particular system which will show that traffic this many are there in a particular state. But what they are doing is manually we can just see. And even if they're trying to use, it is of the IoT based sensors. It is not based on softwares. So
Okay.
those are the changes we have seen. And all these like traffic, air, weather, and waste management is not there is no such application where all four are integrated in one particular dashboard. So they are separate.
Good. So does your application provides all the cities that whichever I name it?
Yes, sir. We can select here any kind of city we want. If you want that particular city, so then you can just use location over here. Okay. If you want to see for a particular city, you have to go and search here, whichever city you want to choose. Or if you want to see for a video or a photo, anything, so you can use your traffic analysis option button, where you're going to upload a data, maybe a video or a photo. Anything is okay. So even the output is been stored here, and it will show us, it will detect and it will show us.
Come again. So I have to upload a video of where there is a traffic congestion.
Okay, sir. So you should for any video, if you have, it should be in your system. And that system, you have to place it in the files, in a particular
No,
folder
no,
file.
please listen. My question is something different. So when you are saying about traffic congestion, am I asked to upload a video of the traffic?
Yes. Yeah, it is video or photo. You can add both. It's left to the user. If he wants to see the data analysis of a video, he can just upload video. If he wants a data analysis of a photo, he can add a photo image.
It is something different. Listen question carefully. So imagine that I am in a commuting. Okay,
Okay.
so just I wanted to know for the next 2 kilometers, how was the traffic? So what is supposed to do by using your application?
Actually, what we are going to do is we are giving the data analysis of a particular. We are not giving a particular in a place. If I just give you an example, there is a city, maybe a city A, but in that city, I'm just showing that this city has a particular high traffic. this Abhi, if we'll just take an example, I have given here as Mumbai. In Mumbai, it is showing me that Bandra Kurla has high traffic city, and the traffic volume is being given so that the person user can skip that place, or can take a shortcut of instead of that. So that is the
Okay,
main
it is
motto.
something like a static. So dynamically, I can't able to check it. Am I correct?
No, yeah.
Oh, okay, okay. Thank you, Sneha.
Okay, thank you, sir.
Over to admin.
Thank you, sir. It's my request to the remaining participants that we are already above the time, so kindly stick to your time constraints. Next, we have Meghna. She is presenting software defect prediction using machine learning algorithms. Do we have Meghna?
Yes, sir.
Okay, ma'am. You can start your presentation.
Am I audible?
Yeah, ma'am, you are audible.
My screen is visible?
Yes.
Thank you. Good morning, everyone. I'm Meghna, presenting software defect prediction using machine learning algorithms. My paper ID is 1000, and I am from Maharaja Institute of Technology, Tandavpura, Department of Computer Science and Engineering, with my teammates Hasina Banu and Anusha. The main agenda is like this. And coming to abstract, the challenge is bugs found late cost millions to fix. Traditional testing is slow. Our solution, we use machine learning algorithms on code metrics to predict which software modules will have defect before deployment. We analyzed historical project data for real-time software modules. We tested multiple algorithms like decision tree, random forest, and SVM and cat boosting. Uh, the result is nearly 90% accuracy, enabling learning outcome outperformance. Single algorithms reduce testing cost significantly. Moving to the introduction, modern software is complex and defect in production are expensive. System crashes, data breaches, and lost revenues. Current problem is manual code review takes week and still miss bugs. Traditional machine learning achieves only 70 to 80% accuracy. Our approach apply advanced assembly machine learning to identify high risk modules automatically. This lets teams focus testing efforts where it matters most. Impact early defect detection, cost reduction, better software quality. Let me give an example, like a real world example of Google browser. Imagine Google Chrome development team. They have thousands of developer working on millions of line of code. A small bug get introduced in the rendering model. Let's say a problem with how it handles HTML elements. Nobody catches it during deployment. What happen is user download Chrome when they visit certain website or Chrome cache crashes. User lost their work and get frustrated because the chromes are crashed. They switch to Firefox or Safari. Google loses market share and reputation damage. The cost is fixing the bug once it is in production. 5 to 10 million dollars are fixed. Development embarrassment, and could earlier detection have helped? Yes, if we have had analyzed the code metrics of that rendering model before release, our machine learning model would have flagged it as high risk. The team would have done extra testing, found the bug earlier when it cost a few $1,000 to fix. Moving to literature survey, we have refer so many papers in that I'm representing two literature survey. In this, the limitations are we found a gaps in these papers. Existing paper achieves high accuracy but suffers from overfitting risk, not fully mitigated. Class imbalanced issues. like not properly handled, no project validation. What we did differ in this means we combined 5 algorithms into a assemble. We handled class imbalance rigorously. We validate cross multiple real world projects using NASA and promise data sets. The existing method faces existing software defect prediction methods includes manual testing, code reviews, and traditional machine learnings. Manual approaches are time consuming, depending heavy on human efforts, time leading to the possible errors, rule based and statistical models. For this we need there is need for more accurate and efficient defect prediction models. The problem is the traditional model defect detection methods are slow and costly and unreliable, creating new for intelligent machine learning based system to predict a software defect early and efficiently. And like before deploying to the market, we have to check for bugs and deploy to market. And coming for the objectives, overall 5 objectives are there: collect the software modules with 220 code metrics, pre-processing data where handling missing values and balanced classes, and development hybrid machine learning model by combining 5 algorithms to accurate for stable and accurate defect prediction, and build automated system for prediction evaluating rigorously with high accuracy and precision, recall, and F1 score. Coming to the system flowchart, like a proposed model, we have given a input data set is like 10,000 data where it is inside the data set, and collect the software data set and pre-process that, like in pre-processing clean the data, normalize features and balance data set using smooth, and train train the machine with 5 algorithms parallelly, like random forest, SPM, decision tree, hybrid model, like light GBM were fast gradient boosting, and combines prediction through assembling voting and evaluate using accuracy, precision, and recall with tenfold cross validation. And coming to proposed um, model is this what I have explained there. Coming to next slide, experimental setup result. Here, what we tested a dataset software models from NASA and Promises, and features 20 code matrices per module, split 70% training and 30% testing, like splitting the data into 30% for testing and 70% of training. Algorithms are used random forest, SVM, decision tree, cat boosting, hybrid model, extra tree, and light BGM. Evaluating cross-validation with 4 matrices. Coming to the result, the algorithm performance like this, or assembly near 90% accuracy. Precision call is 89%. When we say a model is defective, you are right 89% of time. Recall 88%, we catch 88% of actual defect. Um, each algorithm captures different defect patterns. Combined, they are more robust. The 2% improvement over best
Sorry
single.
the 9 minutes are over. Kindly wrap up.
Okay, sir. Thousands more defect codes and large code base. Coming to the conclusion, assembling learning outcome outperform single algorithm defect prediction. 90% accuracy is producing ready exceed commercial tool 70 to 80% using open source tool like Python, uh, and reproducing and assembling real world data set like NASA and Promises. We have moved defect prediction from academic research to practical deploying technology that organization can use today. And future works or deep learning models like LSTM transformer for code understanding, multi-class defect classification, and quantify number of defects per module. Thank you. Any questions, sir?
Yeah, Meghna, thank you very much. What are the primary objectives of your idea?
Sir, actually, we have like as a student, I have built an software where before deploying to the market, I need to test my software whether it is defected or not. If defected after deployment to the market, like after releasing to the market, the huge amount of loss in cost and time consuming. This
Yeah,
is
I am sure that you might have come across the various mechanisms that what are supposed to incorporate while testing an application or a model. Okay, so pertaining to your idea, you have not specifically mentioned that which application it is aimed for. So is there any such data set or a novelty that these tests must undergo to a specific kind of a domain? Did you
sir.
come
It's
across any such?
sorry, sir. Can you please repeat?
When you are testing in any application,
Okay.
it must undergo through couple of tests pertaining to its scope and feasibility, correct?
Yes, sir.
Okay, so coming to your idea, so did you mention that this application is only suitable for so and so domain or any specific such kind of an application?
Sir, it's not specific. Like when we have built an any software, any kind of any domain of software, the time complexity, space complexity, and all they declared so that when they give their software dataset, it can predict whether it's the software is defected or not.
Do you think that that is one of the feasible parameter to check?
There, there are many other features where we can check.
Because if you're not confined to a specific boundary, it will be something like out of the scope. It is always better to have a list of parameters or the checklist which are suitable to a particular application. For example, if it is a software application where it is used to build an online shopping cart, it has got its own set of parameters. If at all you are dealing with something else, it has got few more additional parameters. Some of them may be common, but at a general context, we are not confined to only few as the whole of the every context.
Yes, sir.
Thank you, Meghna. Thank you.
Thank you, sir.
Thank you, sir. Thank you, ma'am. Next, we have Ipsita Mohapatre. She is presenting Technology Empowered Teaching and Learning in Language Education or Systematic Review.
Hello, sir.
Yeah,
Am I
ma'am.
audible?
Yeah, ma'am.
Yeah, just give me a minute. Okay, is it visible?
Yeah, ma'am.
Yeah. So good afternoon, everyone. Today I'll be speaking on technology-aided communication and its educational utility. Myself, Dr. Ipshita Mahapatra, and my colleague, Dr. Dipanjali Mishra, we both are from School of Liberal Studies from KIT University. And this, my presentation, my paper is a theoretical one that focuses on how digital technologies and AI-driven tools are reshaping communication in education, and it influences the teaching, learning, assessment, and institutional practices at both national and global levels. So, coming to the introduction of this paper, so the digital revolution in education. Education has undergone a major transformation due to globalization and technological advancement. So traditional chalk and board methods are increasingly being replaced by digital and technology mediated learning environments. So artificial intelligence, adaptive learning platforms, and digital communication tools have changed not only like how education is delivered, but also how it is created, shared, and evaluated. So importantly, this transformation extends beyond classrooms to mentoring, then examination and examination cells. We also are using various technologies to, evaluate the papers, then student view, rechecking and everything. Then quality assurance is also there, quality assurance for the qualitable, like research, publications, patents, projects, and all for everyone, for the teaching staffs, and institutional governance, of course. So redefining educational communication. So here, there are three segments where I need to focus on. So breaking barriers. So the technology has redefined educational communication by breaking geographical, time, and cultural barriers. So students and teachers can now collaborate in real time across countries, creating global knowledge networks. Then personalized pathways. So one of the strongest advantages of technology is personalization. So AI-driven platforms like ChatGPT and adaptive learning systems tailor content according to learners' pace, style, and preferences. So this supports differentiated learning, and it helps address individual learners needs more effectively than uniform teaching methods. Then interactive engagement. So technology also enhances interaction. So platforms such as Zoom, Microsoft Teams, and Google Classroom transforms learners from passive listeners into active participants. So real-time discussions, collaborative tasks, and instant feedback improve this engagement and deepen this understanding. Then coming to the theoretical foundations, we have three foundations here: constructivism, connectivitism, and media richness. So coming to constructivism, from a theoretical perspective, constructivism explains like how technology supports learning. And according to Vygotsky in 1978. So learning occurs through active engagement and social interaction. Like digital platforms enable discussion forums, collaborative projects, and simulations where students actively construct knowledge together. So then coming to connectivism, it was proposed by Simons. So he viewed knowledge as residing in networks. So in the digital era, so the learners constantly interact with both human and technological sources of information. So learning becomes a process of navigating, connecting, and updating the knowledge. So within these networks. Then media richness. It suggests that communication effectiveness depends on the medium used. So rich media, like such as video conferencing and interactive platforms, so they provide immediate feedback, multiple cues, and personalization. So these features make educational communication more effective and meaningful. So global evidence. Globally, several institutions demonstrate the educational value of technology. MIT Open Courseware provides free access to learning materials worldwide, promoting self-directed learning. edX initiatives by Harvard and Stanford improved learning outcomes and higher student engagement. The University of Helsinki reported higher course completion rates through AI-based adaptive feedback systems. So in Indian context, there are Swayam and Diksha. So in India, platforms like Swayam and Diksha represent major digital initiatives. Swayam has reached over 10 million learners through MOOCs across disciplines. And studies show that many students feel more comfortable collaborating virtually. So Diksha has revolutionized teacher education, especially benefiting rural and resource constrained areas where multilingual digital contact, through multilingual digital contact. So then the TSC framework. So to understand technology-aided communication holistically, this presentation proposes the TAC framework. So, so TAC framework consists of these 5 components: pedagogical design, interactive engagement, then personalization and adaptivity, assessment and feedback. So the pedagogical design focuses on organizing learning activities that effectively use technology. So it includes synchronous and asynchronous modes and emphasizes active engagement rather than passive content delivery. Then interactive engagement. So this dimension highlights the shift from one-way teaching to dialogic interaction. So learning management systems like AI chatbots and live polling tools promote continuous interaction and strengthen academic communities. Then personalization and adaptivity. So this use AI and analytics to tailor the learning pathways, and these systems adjust content based on learner performance, pace, and preferences. So improving motivation and learning outcomes. Then assessment and feedback. So technology enables continuous and formative assessment. So online tests, simulations, and real-time analytics provide timely feedback, supporting data-informed teaching and learning decisions. Then humanistic ethics. So the final dimension emphasizes ethics. So while using technology, institutions must ensure data privacy and accessibility, inclusion and fairness, because technology should support but not replace the human connection, empathy, and pedagogical judgment.
Ma'am, sorry to interrupt, but your
Mm.
minutes are over. Kindly wrap up.
Okay. So, sure. So critical challenges. So despite its benefits, technology presents the challenges: digital divide, algorithmic bias, data privacy, and human dimensions. These are the various challenges and ethical considerations. Then talking about the future directions, future educational systems must balance innovation with equity. Personalized learning ecosystems should preserve the human judgment. Then digital inclusion policies must address access and literacy gaps. Ethical AI frameworks are essential to ensure fairness and transparency. Thank you. So to conclude, this has transformed education by enhancing access, engagement, and personalization. Thank you very much.
Thank you, ma'am.
Thank you.
Do you have any questions? Sir, do you have any questions for presenter? I take it as no. Okay, so next will be the last presentation for today. Next we have, just let me share my screen. Yeah, so next we have Pavitra Shivakumar Mundasada. She is presenting bone marrow cancer detection using deep learning algorithms. Do we have anyone from her side?
Yes, sir. I am.
Okay, ma'am, share your screen. Hello.
Yes, sir. I am sharing.
Ma'am, I think you have some technical issue. Your voice is breaking.
Uh, Sir, am I audible now?
Yeah, now you're audible. Your screen is loading, ma'am. Yeah, it's visible now, ma'am. You can continue.
Okay. Good afternoon, everyone. So I'm Pavitra, and I'll be presenting our project named Bone Marrow Cancer Detection using Deep Learning. So here I'll be explaining how we use deep learning and clustering techniques to automatically detect the cancer types from microscopic images. Okay, and coming to the agenda, I'll be starting with the abstract and then followed by introduction, and then the existing research works, and then what is the problem statement and what are all the objectives, then to the proposed method, what have we done, and the result and what are all the future works. Okay. So coming to the abstract, bone marrow cancers such as leukemia, lymphoma, and multiple myeloma are the life-threatening diseases that require early and accurate diagnosis. So traditionally, diagnosis depends on manual micro examination, which is more time consuming and it is subjective. So to address this, we yes, sir. Am I audible now?
Yes, ma'am, you can continue.
Okay. This is the abstract of our project. And then coming to the introduction, bone marrow, it is responsible for mainly producing the blood cells, and the cancers affect the cancers, the blood bone marrow cancer will affect that blood formation. So there are mainly three major types. One is leukemia, lymphoma, and multiple myeloma. So currently diagnosis relies on heavily on the expert pathologist examining bone marrow smears manually. So, however, this approach is slow and subjective and difficult to scale. So, with recent advancement in AI, especially in deep learning, we can automatically learn visual patterns from the medical images and assist doctors in faster and more consistent diagnosis. And then, so next, coming to the literature survey, several researchers have applied deep learning techniques for blood bone marrow detection, and here mainly CNNs transfer learning models like ResNet, EfficientNet, and segmentation models like Mask RCNN have shown high accuracy. So some studies combine machine learning and deep learning to improve the robustness. And however, challenges such as data imbalance, stain variation, or lack of severity estimation, they still exist. So these gaps motivate our approach of combining classification with severity analysis. And then coming to the problem statement, the main problem is that manual bone marrow cancer diagnosis is time consuming, subjective, and highly dependent on expert availability. So, there is a risk of delayed or incorrect diagnosis, especially with increasing workloads. So, existing automated systems often focus only on classification and ignore invalid images or disease severity. Hence, there is a need for an automated, reliable system that can classify this multiple cancer image types and detect which is invalid, which is valid type, and also with their severity in that particular type of cancer. Then coming to the objective, firstly, it is to automate the bone marrow cancer detection using the deep learning algorithms, and then to classify it mainly classifies which type of the cancer it is, and then uh, next to reduce the human error and also the time consumed, and then finally to develop the lightweight model that can be practically used in clinical or academic environments for better doctor decision making. We can go with this. And coming to the proposed methods, it did consist of several stages. Like we start with the image pre-processing, including resizing, normalization, and then we use custom lightweight CNN with three convolutional blocks for multi-class classification. Then for image classified as cancerous, we will apply the K-means clustering in HSV color space to estimate. Then mainly to estimate the severity based on that affected pixel regions. Then the final output will include the predicted class, the confidence score, and also the severity level of that particular cancer type. Then coming to the experimental setup, so we have used data set approximately 2,540 microscopic images And data is split into training, validation, and testing sets using stratified sampling. We use the Adam optimizer with categorical cross entropy loss. And also, performance was evaluated using accuracy, precision, recall, F1 score, and confusion matrices. And then these are all the samples of data sets we have combined. We have trained the model, different types, samples of different bone marrow cancer type, and the one is invalid one, and the other one is the non-cancerous sample. Next, coming to the system architecture. So this is the system architecture of our project, where the user will upload the bone marrow image through the web interface, and the Flask application will handle pre-processing and then sends that image to the CNN model for classification. If the cancer is detected, the severity estimation model using k-means clustering is triggered, and then finally, the results will be displayed to the user with class, which class it belongs to, like which type of cancer it belongs to, and also with its confidence level and severity level. And then coming to the confusion matrix. So this shows the classification performance of our model on the test set. Most predictions lie along the diagonal, indicating the correct classification, and this demonstrates that the model can effectively distinguish between different cancer types as well as non-cancer and non-valid images. Then coming to the accuracy. So this chart represents the overall accuracy, and this is the performance chart. We have achieved almost highest accuracy with the precision, recall, F1 score, which
You
is
are
close to one of. Yes,
hello,
sir.
ma'am. 9 minutes are over, so kindly wrap up.
Oh, okay, sir. Thank you. So these results confirm that our lightweight CNN performs well despite having low computation complexity. And then coming to the results, overall model has achieved highest classification accuracy on the test data set, and ROC curves indicate the strong class separation, and the severity estimation model successfully categorized the cancerous image into mild, moderate, and severe based on the affected pixel ratios. And this also makes sure that our system is more informative than simple classification models. And finally, to conclude, we have proposed an automated bone marrow cancer detection system using deep learning. Our lightweight CNN effectively classifies the types of the bone marrow cancers, and this system reduces manual effort and diagnostic time while providing additional severity information. So, if it demonstrate the potential of AI-based tools to support medical diagnosis, and this is the reference is the papers we have you consider for our work, and thank you.
Thank you,
Thank you, sir.
ma'am. Sir, do you have any questions? Sir, do you have any questions?
Hello, sir. Am I audible?
Yes, sir. Yes.
No, no. Go ahead. Go ahead.
Okay, sir. Thank you. Thank you, ma'am. You can stop your sharing. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for support during the 10th version and the all previous 9 versions of the conference. We will be happy to see you in the 11th version of the conference. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. So kindly cooperate with the team ICTCS 2025. I also thank our session chair, Dr. Uh, Srinivasulu Gugula. Just a small token of appreciation from Team ICTCS and Global Knowledge Research Foundation. Let me share my screen. Yeah, so this is your token of appreciation. So, do you have any closing remarks?
Thank you, ICTCS 2025. I would like to thank all the organizers, coordinators, and the participants, authors for giving me this opportunity. I'm really honored and privileged to part of ICTCS 2025. Uh, After looking at the authors' ideas and their novel presentations, it's immense and pleasure for me. All the papers has got unanimous response, as well as they have got huge visibility. So once again, I would like to thank all the team who helped this ICTCS 2025 a grand success. Thank you.
Thank you so much, sir. I request everyone to turn on their cameras so that we can have a quick snapshot of the session. Thank you, everyone, and have a safe day.
Thank you.
ಅಯ್ಯೋ ದೇವ್ರೆ